Okay, so welcome back guys again to my channel. So from this video onwards we're going to start our binary exploitation categories. Okay, so we're going to see throughout the binary exploitation category what is stack overflow, what is heap overflow. Okay, and in stack overflow there is a common vulnerability known as buffer overflow. Okay, so if we know this all types of exploitation and vulnerabilities, we will be going to cover all the playlist in this video. So without wasting much time, we're going to get started. Okay, so the buffer overflow are of mainly of two types. The first one is stack overflow and second one is heap overflow. So we're going to start from the stack overflow. So for that I have some challenges for you all. You all can go to the website www.rockemporium.org and download all the files. Okay, so over there you're going to get all the ELF files, which are Linux executable files. From there you all can download all the files and we're going to practice one by one on it. So I have already solved some challenges on that, so I'm going to explain how I had solved all of these challenges. So without further ado, let's get started. So I'll just fire out my terminal over here. Let's zoom this out. Go to desktop. Okay, so we'll first going to see a return to win attack. Okay, so let's me go to this directory. Okay, so now what is exactly buffer overflow vulnerability? Okay, so when the attacker puts more amount of data into the input side. Okay, so assume that you have a C program which takes inputs of 10 bytes. Okay, and using the gets parameter. So when the attacker tries to enter more than 10 bytes, like 12 bytes or 13 bytes, the more bytes have been overwritten on the adjacent memory. Okay, so now you'll be going to think that so how it can be dangerous. Yes, it can be dangerous because it is trying to override the instruction pointer which is present after that buffer size. So now what is instruction pointer? So instruction pointer is a pointer in the stack which points to the next instruction to be executed after that particular instruction, like after input where the instruction pointer will go. So what as of attacker can do is that he can enter a large amount of data until that buffer, and after the buffer the instruction pointer, so on the instruction pointer he could write some particular memory address on which he can point towards, like to know a function which executes a shell. Got it? So it can try to execute a certain amount of shell, or it can try to gain access to other unauthorized function which developer doesn't wants to get executed by the user. So I'm going to start with that. So I have already solved this, so I'm going to explain you all step by step without creating the Python script, and the Python script I'm going to create afterwards because it's too high. So we'll first going to solve step by step. So as you can see, this is red to win binary, right? So now our goal is that to get out this flag.txt. Now if I do cat flag.txt, I'll get a flag, but we don't need to do like that. We need to try to exploit this binary which is return to win binary and then get the flag out through this binary. So what is the first step in every binary exploitation is that, so we need to check the permissions of the file which are set by the developer during the compilation. So there is a command known as checksec file equals to, and then you have to specify the name of the file. So in this it is right to win, right? So I can just say right to win and hit enter. So it will take a bit amount of time. So you can see it shows the architecture on which it is there, and the partial reload is enabled. So there are many stack protections like ASLR, NX bit, then pi, which is known as this a partial independent executable. So these are memory addresses. And okay, so as you all can see is that the output is in such a case that architecture is of AMD 64 bytes, which is in Little Indian. Okay, then Relo is there, stack is there, NX is there, and Pi is there. So these are all known as stack protections. Okay, for in this video we're going to just focus on two stack protections. They are no canary, okay, and the Pi. Okay, so no canary is a type of a stack protection in which, like, if the attacker enters a particular amount of data, and if the data gets overflow on the adjacent side, so it does not check for the data which is been overflowed on the instruction point. Okay, so where the canary is present, it checks for that canary. So canary is a particular value, it get executes when the program is being running mode, right? So when the attacker enters large amount of data, and if that canary value has been changed before the instruction pointer, so it will going to stop out the program and prevent the buffer overflow. Okay, so in this case the canary has not been found, so the buffer flow can happen in this way. So now what is Pi? So Pi is position independent executable. So in Pi the memory address will going to remain same. Okay, even if I close the program and start again the code, the memory address will not be going to get changed. So that is also a good sign for us, as I'll be going to explain how we can use that in forward. Okay, so these are two main protections which have been disabled, so buffer overflow can happen easily. So for your information, what is NX? So NX is a bit in which it makes stack non-executable. So if you try to write some shell code on the stack, like to spawn the bin sh, okay, for over that the NX bit has been enabled. So if you try to upload a kind of a shell code or any kind of instruction will get going to execute, so it will not going to happen. Okay, so I've explained you all this some protection, right? So let's clear this out. So now first step is to check the binary. So let's run this binary. So as you can see, these are some of the instructions given over here. So let's try to enter some, okay, data. So as you can see, the program got executed normally. So we want the program to be executed like throwing some error. Okay, so we're going to fill that with lots of A. Let's see if it gets executed or not. Yeah, so as you can see, we are receiving an error name as segmentation fault. So the instruction pointer don't know where the program should get executed. Okay, so if you all just try to do like DMSG, I think DMS D message, okay, and then that could take. Okay, so you all can see the last error which was thrown by this binary. So you all can see general pointer, general protection fault, which is instruction pointer is pointing to some particular address which is not known by the instruction pointer, so where it should get executed. So to get a clear overview of this buffer overflow, I'm going to introduce a tool called as GDB. So GDB is a command line debugger. So it is a very popular tool and it comes with many other extensions like Jeff, Pond Debug, and I think so it's a GDB Peda. Okay, so these are three main tools, not tools, like, so they are plugins for that. So I recommend you all to use Pond Debug, so because it is very easy to use and to create cyclic patterns and get offset. Okay, so I'll just say sudo GDB, then followed by name of the file. So in this case it is red to win, hit enter and the password, right? So as you all can see, this is the Pond Debug interface. Okay, so the every first command to check in the binary is that, so we should know what are the functions which are present. So for that we will be going to use info functions command. Okay, say info functions, hit enter. So as you all can see there are many functions. So in this case, the main function will be going to be main function pawn me and rat to win. Okay, so as everybody knows that the execution of the code get starts from the main function, right? So what we can do is that disassemble main. Okay, so if you all are familiar with machine level instruction, which is known as assembly. Okay, so as you all can see, it is taking input, okay, and then it's trying to say like enter that value, as we have all seen like that, you know thanks for using and all that strings. Okay, so first it's trying to set the buffer, and then it's printing out that input message. Again it's printing that, and then it's trying to take input in the pawn me function, and then it's trying to print it, thank you and all. So I'll just show you one example. So if I just copy this instruction, which is which is present in EDI. So if I just say examine at this instruction, so you all can see exiting, and we also seen this string when the program was getting like at the end of the code. So at the end of the code, you all can see this has been getting executed, right? Okay, so now what we can further do is that, so we can see there is a set buffer. Okay, so in this buffer it is trying to allocate that bytes, and pawn me function is trying to take the input. So let's see the pawn me function. Disassemble pawn me. So as you can see, it is allocating the buffer of size and all. So we'll be not going to through this code. Okay, so now as I've already shown you all, there is one more function known as rat to win. So now you will be wondering that what is that rat to win function, right? So if I just do disassemble rat to win, so you all can see there is a system call mate over here. So now if some of you all have been familiar to C language, the system call we make when we want to execute the system commands. Okay, so as you all can see, the first argument, which is in EDI register. If you all don't know the assembly, I please request all of you all to learn the assembly basics like instruction, the pointers, and what are registers, RBP, stack pointer, frame pointer, everything. So please note that the whenever we try to call a particular function in assembly, the argument should be first passed in the EDI register. Okay, or even RDF for 64 bits. So in EDI register, we can see that one address is being passed. Okay, and that address will be going to pass as an argument in the system function. Okay, so let's copy this. Okay, let's try to copy this address and examine this address, what is doing at that address. Okay, so if we see at this address, we can see it's trying to execute like print out the flag.txt file. Okay, so we'll be going to see that flag, right? So now whatever attacker tries to enter more amount of data, and at a instruction pointer he puts the address of return to win. Got it? So when the attacker puts the return to win address at the instruction pointer, right, and then the program execution will be got flow from the return to win. So we can get access to the flag.txt file, right? So as we can see, and then it will going to come inside this function, and it will going to execute cat flag.txt, and will going to get that flag.txt, that output flag. So first of all, we'll going to create a cyclic pattern. Now what is cyclic pattern? A cyclic pattern is like a combination of some bit of characters, and when the cyclic pattern, so I'll just show you, okay, cyclic, and I'll generate a pattern around 50 bytes. Okay, so this is a pattern of 50 bytes. So as you can see, A, then B, A, C, A, D, A. Okay, so I'll just copy this. Okay, and just see. So then I want to run the binary inside the pawn debug. So there is a command known as run or R. So just press R and hit enter. So as you can see, it is taking the so it is waiting for the input, right? So now just paste that whole string, that cyclic pattern string, and hit enter. So as you all can see, the program gets crashed over here. So at the return instruction, it is saying that 61616161. So it doesn't know where to point exactly. So when you see RSP, which is known as stack pointer, which is just above the instruction pointer, so from that we have to copy all this text, okay, and then we should just say cyclic cycl cyclic hyphen l followed by that bytes. Okay, so we have to just specify that 8 bytes only. Okay, so I'll just clear out the some of the bytes. Okay, so as you all can see, when I give the 8 of the bytes, right, so it is like so as we can see, the offset is 40. So these states that after the 40 junk values, so the 41st value will be overwritten on the instruction pointer. So it states that. So now what we can do is that we can just come up over here and just try to copy this return to win address. Okay, we can just open a text editor over here. So now I can just say out like red to win address is this. Okay, so now I know the return address. So now the main content over here is to do is that now we have to overflow to the 40 bytes. So that 40 bytes is known as offset of that buffer overflow. Offset is 40 bytes. So now what is offset? So offset is like how much value is needed to overflow the instruction pointer. Okay, not to like overflow on it. So at how much byte we can try to write on the instruction pointer from the next line onwards. So it is 40 bytes. So after 40 junk values, we can write a instruction pointer this address. Okay. So now we know the return to win address and the offset. So after 40 of A's or B's, we can add this address. But if we try to do like manually by typing this 40 A's and then address, it will be going to execute, because whenever the program tries to take the input, it takes as a string, not as bytes. But in the stack, we have to tell it as a bytes. Okay. So for that, there is a Python code over here. So I'll just try to. Okay, I'll just open a new terminal over here. Desktop drops then right to win. Okay, so now what I'm going to do is that I'll just say Python 2. Now why I'm using Python 2, I'll tell that afterwards. Okay, okay, sorry, we'll take Python 3 only, and then we're going to use it in command line interface mode. Okay, hit 2 colons, and now we know that the offset is 40, right? So what we can do is that we can just say print out is until 40 times. Okay, then we need to specify that address. So we can just specify the address. So now if we specify the address in this way, it will going to throw out the error. I'm just going to show you. See, cannot concatenate the string to integer. So now first we're going to convert this address into little Indian format. So what is little Indian format? So little Indian format will be like after 2 bytes \x \x. Okay, so that instruction will be going to store in the reverse format in the stack, and that after the 40 bytes it will going to read all the values from the reverse bytes, and then from there it will going to understand so that address will going to execute from return to win. So then it will then the program will going to jump to the return address. Okay, so I'll just now what we're going to do is that for that we're going to need some libraries. Okay, not libraries, modules in Python. So first of all, we're going to write the output as bytes. So if we use print, it will going to print as strings, right? So we need to output should be in the bytes format. So for that, we're going to use this, and then I'll just use one more module, yes, and it is struct, to convert that hex into little Indian format. Okay. So now to print there is a shipment over there, so which is known as sys dot, I think so it is a system sys dot out dot buffer dot write. Okay, sys dot out dot buffer dot write. So let's check out this works or not. So I'll just going to print a. Okay, only 40 bytes. So you can see okay, it's saying sys has no attributes out. Okay, so I think so it is std out. Okay, let's see std out. Says string object says no buffer, um, object required not str. Okay, fine. So what we can do is that we can just try to give this tag values. A is not defined. Okay, I don't know why it's throwing this type of error. Let's say a byte like object is required. So I think so we need to write dot bytes it is. Okay, it's not as bytes, not get to bytes. This dot std out dot buffer dot write, it's not working that way also. Okay, what we can do is that we can just say sys dot buffer dot std out dot write might be std out dot buffer dot write. But it's not working in that way also. Okay, what we can do is that we can just say out like input sys std out dot buffer dot say like okay, it says a. Oh, why it's not taking as a bytes character? Okay, okay, so we need to specify that b. Okay, over the bytes. So like so if we say b into so offset was of 40 bytes. So if we say 40, and so as we can see the 40 bytes has been printed. Okay, so after 40 bytes we need to print out that address of the return to win function. Okay, so I'll just import that one more module known as struct import struct for struct. Okay, so now before importing that, so I'll just going to store that instruction pointer. So it is like address. Okay, address of rat to win equals to uh, struct dot pack. I'll just explain what I'm doing over here. Okay, little Indian format, then followed by the address. Okay, so I've got this and I stored in this address, then semicolon again, buffer dot write 40 bytes, then concatenate with to addr underscore ret to win. Sorry. Okay, so as so I'm going to explain. So first, it is trying to set this mode into the command and interface mode. Okay, and then it's trying to import this sys module for to write as buffer in the output file, and then it's trying to import the struct variable to convert. Okay, so over here struct.pack. So structure pack it in little Indian format, so that greater than I stands for little Indian format, and then the second argument is the address of the return to win function. So this will going to pack that, and it will going to return that in little Indian format, and that I've captured the output in addr underscore rat to win. Okay, after that semicolon, then sys.stdout.buffer.write. Okay, so it's trying to print the whole buffer. Then in bracket I've concatenated with the buffer, followed by 40 junk values of a until it reaches to the instruction pointer, and then followed by the address of return to win function. So this whole output is giving me this, but over here, as you all can see, it is not showing that actual bytes, because our shell does not show like actual bytes. So it gets breaked up and shows like small characters and all. So you don't need to worry of that. So if you all want to see the output, you all can do is pipe it to xxdi, I think so, and hit enter. So it will going to show you all that instruction pointer address over here. Okay, so it is like 56, as you all can see, 56, then 07, then 07, then 40, so that full address. Okay, so it is in correct way. So now what we can do is that now we should pipe this output to our binary. So we can just say write to win, hit enter. So as you can see, it says segmentation fault again. So now we need to check the code again. Okay, so let's see whether it is 40 bytes or not. So if I run again, let's copy the 8 bytes, 2, 3, 4, 5, 6, 7, 8. Selection CYC, LIC, hyphen L. You see exact at 40 bytes it's trying to catch the full code. So as we can see, the code is totally correct. Okay, so now there is a fault over here. So I just forgot out that. So whenever we try to jump at the instruction pointer, there is some misalignment of stack. Okay, so for that, before jumping on the some new function address, we need to first jump on the return address, or on any return address. So now what we can do is that now we can just go on this function over here and just try to copy any of the return address. So as we can see, I'm having the return address of this function only. So copy any of the return address instruction only. So as we can see, RAT. Okay, so we should copy that address only, come into next terminal over here, and then just you know after, before adding the return to win address, we need to point out to that you know return address first, and then it will going to jump on the return to win address. So from that we're going to see the flag. So I will just add a variable over here saying that red, okay, means return address. So over here I'll just going to just say red is equal to struct struct dot pack, then little Indian format followed by this address. So now if I hit enter over here, think so we have got more error over here. Okay, so I've messed up over here with because I didn't add the semicolon over there. Sorry for that. Okay, and then if we hit enter, we again see that there is some particular wrong going in that. So like I'll just see. Okay, let's just try to change the address over here of that return pointer. Might that might work. Okay. Uh, disassemble main. Okay, so I'm going to give the return instruction of the main. Then I'll just come over here and just give that return instruction of the main address. Okay, enter. And still we can see that there is some problem going over here. Okay, now what we can do is that I'm going to create a script for that to get the flag. Okay, so now what I can say is that like so as you can see I've already created the script to get flag, so I'm going to create some new script. Okay, so I'll just say touch exploit.py expl exploit.py. Okay, sudo permissions required. So the file I've already created. Now I can just say nano. So there are pawn tools, okay, over here for this. Sorry. Okay, so there are pawn tools for the binary to analyze. So it is just type from pawn import everything. Okay. So then we're going to analyze that binary. Okay. So for that it is elf is equal to context dot binary equals to capital L, and then give the name of the binary. Okay. Return to v. Then we need to so we have already analyzed the binary and we have stored that output in else. Okay, so now we need to create a payload for that. So we can just say payload equals to, now we need to first add the cyclic patterns until 40. So we can just say a junk bytes of 40. This is also enough for that. And then we need to jump where on the return address. So I just say ret. Then we need to jump on the that flag address. Okay, so I can say ret to win area. So now I'll just get the all the addresses. So return address is this. Copy any of the return addresses because it will not going to create any kind of issues and all in your code. So just copy this address one more. This is the ret to win address, and then this will be now we need to copy that ret to win function address, right? So I'll just say ret to win and then copy this address. So now just paste the address over here. And now what we need to do is that now we need to start the binary. So we should type IO is equal to process. So process will going to start the binary and IO is that object for that. So now IO dot read line, we can say read until. So we need to read until that input statement. So I'll just run this binary again over here. I will run this binary again. So we need to take input until this less than sign. So just copy this, come over here, then just type this. Okay. So we need to take input until this. So after reading till that line, we need to send the payload, which is our input. So we'll just say IO dot send line and then payload. Okay, so it will going to send this whole payload, okay, over there, and then we should make it interactive. Okay, so if we want to get shell and also it's a good habit to type IO dot interactive. And then we can just execute this script saying that Python 3 exploit.py. So I'll just use sudo command. Okay, I've just messed up over here. Okay, so I've entered the wrong name for the variable. It happens when you just try to do it. So it is red to win underscore area underscore area. So now I'll just try to run the script. Okay, so now as you all can see, thank you. Well done. Here is a flag, and this is a ROP, a placeholder 32 byte flag. So this was all for today, guys. So in this way, we have exported a simple buffer overflow. I know this video will be going to be too long, but I hope that I have explained in detail of every part of this video. There was some kind of errors in this video which I faced for the first time while recording this. So please don't get sad on this. Okay, so well, guys, this was for it today. In the next video, we'll going to create some rock chains. Okay, I'm going to explain that also. Then we'll going to do heap, overflow, then format string vulnerability. So there will be a bunch of videos coming on this channel. Till then, keep watching and keep enjoying. And if you are new, please subscribe my channel. Thanks.